Hello friends, welcome to Doubt Forum. In this question, we are asked to find the normal reaction applied by the surface of this lift on this 10 kg mass, and this lift is moving in the upward direction and having an acceleration equals to 0.2 meter per second square. Before we solve this problem, let's read out the question for more clarity. And the question is, 4 planks are arranged in a lift which is going upward with an acceleration equals 0.2 meter per second square as shown in the figure. We are asked to find the normal reaction applied by the lift on the 10 kg block. The value of G can be taken as 9.8 meter per second square. As this question is based on the normal reaction, so first of all we have to understand about the normal reaction. A normal reaction is a type of contact force. Whenever there will be a contact between two bodies, the normal reaction will come into picture. Just take this example. Suppose this is the ground, and on this ground there is a mass is lying over it. Because of the contact between the surface and this mass, there will be a normal reaction. So this surface will be creating a normal reaction on this block. Not only that, this block will also be creating or exerting a normal force on this surface. Let's take another example. Suppose this is the corner of a room, and if in this corner there is a block lying, so as we can see there are two contacts. The first one is this and the second one is this. So in both the contexts, the normal reaction will come into picture. Second thing about the normal reaction is that its direction. Its direction is always perpendicular to the contact. As we can see here, because this is the contact, so the direction of normal reaction would always be perpendicular to the contact. Similarly, if you want to mark the normal reaction by this contact, so it will be in this direction. Similarly, for this contact, the direction would be in the upward direction. Okay. Now, the next thing is the magnitude. How can we find the magnitude of the normal reaction? For magnitude, let's consider this example. Suppose this is a table, and on this table there is a book lying. Suppose this is a book, and I am considering the mass of this book is m. As we all know that because of its mass, there will be a force of gravitational in the downward direction. The magnitude of that would be m into g. The second thing is that because of this contact between the surface of the table and the surface of the book, there will be a normal reaction applied by the surface of the table on the surface of the book. So that reaction would be perpendicular to the contact, so it will be like this. So this would be N. If this book is not moving in the vertical direction, it means the net force on this book in the vertical direction is equal to 0. Because from Newton's law, F, that is the net force, equals to mass into acceleration. So if the net force on any object of mass m is 0, so that object will not be having any acceleration. If this book is not moving in the vertical direction, it means the total net force in the vertical direction is always equal. It means that the upward force, that is the N, has to be equal to the downward force, equals mg. So this way the magnitude of normal reaction can be calculated. Let's take another example of a lift. Suppose this is a lift. Inside this lift there is a boy. The mass of this boy is m. Because of this mass, if we just draw the free body diagram of this boy, because of its mass m, there will be a downward force equal to m into g. The second thing is that, as we can see that there is a contact between the body of the boy and the surface of this lift. So this lift will be exerting a normal reaction on the body of this boy, because the direction of reaction force is always perpendicular to the contact, so it will be in the upward direction. So let's take this is N. If this lift is not moving, or if it is moving with a constant velocity, it means then the acceleration would be 0. The condition for acceleration to be equal to 0 is that either the lift is moving with a constant velocity, or if this lift is stationary or having no velocity, or we can say it is having a constant velocity of 0. In both the cases, the acceleration would be 0. And from Newton's law, if the acceleration is 0, it means the net force in that direction should be equal to 0. If this lift is stationary or not moving, it means the total net force in the vertical direction in the body of this boy should be equal to 0. So from here we can see that the total upward force, that is the N, has to be equal to the total downward force, and here the downward force is the M into G. So this would be the value of normal reaction. Now take the second example. Suppose this lift starts moving with a certain acceleration, let's say with a 2 meter per second square in the upward direction. When this lift starts moving with this much of acceleration, the body of this boy would also be moving with the same acceleration in the same direction. So if the acceleration of this lift is 2 meter per second square, so the acceleration of the body of this boy would also be 2 meter per second square in the upward direction. And from Newton's law, the force required for a body of mass m to have a certain acceleration is given by its formula F equals m into A. From here, the force required on this body of mass m for this much of acceleration is given by m into 2, that is 2m. So 2m Newton force is required in the upward direction on the body of this boy. Then only the body can move with an acceleration of 2 meter per second square. So here we can see that because here there are two vertical forces acting on the body. The first one is the gravitational force. The second one is the reaction force applied by the surface of this lift on the body of the boy. So we can see that there has to be a net force equal to 2m in the upward direction. So the total upward force, that is N, has to be greater than the total downward force, that is mg. And the difference should be equal to 2m, then only the body of mass m can accelerate with a magnitude of 2 meter per second square in the upward direction. So here what we can find out that N minus mg has to be equal to the net force required, that is 2m, or from here we can derive the value of N, that is equal to 2m plus mg. So this would be the magnitude of the reaction if the lift is moving in the upward direction. Now consider a case when the lift, instead of moving in the upward direction, if it is moving in the downward direction. Suppose the lift is moving in the downward direction with an acceleration of 3 meter per second square and a body of mass m is inside that lift. So what will happen? Because of its mass, there will be a downward force equal to m into g. The second thing is, because of the contact, this surface of lift would be exerting a normal force on the body of boy, which will be in the upward direction. So let's say it is n. As we can see that if the lift is moving with this much of acceleration in the downward direction, it means the body of boy would also be moving with the same acceleration in the same direction. So from Newton's law, the force required for a body of mass m to accelerate with a 3 meter per second square magnitude, the force required would be 3m in the downward direction. So from here we can see that the downward force has to be greater than the upward force with this much of magnitude, or we can see that the downward force mg has to be greater than n, or the upward force. The difference should be equal to the force required for the body to move with this much of acceleration in the downward direction. So from here, mg, that is the downward force, minus the upward force, that is n, this has to be equal to the force required, that is 3m. From here, the value of normal n would be mg minus 3m. This is how we can find out the value of normal for different scenario. Now coming back to the question. It is given that this lift is moving in the upward direction with 0.2 meter per second square acceleration. And we are asked to find the normal reaction applied by the surface of the lift on the 10 kg block. The one thing we always need to keep in mind that this surface will feel not the 10 kg mass, however it will be feeling 10 plus 20 plus 20 plus 20, that is the 70 kg mass. For this surface of the lift, this 10 kg mass is not the 10 kg mass, it will feel it as a 70 kg. So we have to assume that there is a lift, suppose this is a lift, and inside this lift there is a mass 70 kg inside it. So for this 70 kg mass, there will be a downward force due to its weight, and that would be equal to m into g. Here the mass is 7, the value of g is 9.8. Due to this contact between the 10 kg block and the surface of the lift, an upward reaction force would be there. So we are assuming it to be N. Apart from that, this lift is moving in the upward direction with 0.2 meter per second square magnitude. It means this block or the total masses inside this lift would also be moving in the upward direction with 0.2 meter per second square acceleration. So from Newton's law, we need to find the force required for this 70 kg block to move in the upward direction with this much of acceleration, and that is given by force equals mass times acceleration. Here the mass is 70 kg into acceleration is 0.2 meter per second square. So from here the value would be 14 Newton. So the total net force on this 70 kg block in the upward direction has to be 14 Newton. Then only this 70 kg block can move in the upward direction with 0.2 meter per second square. It means the total net force in the upward direction would be greater than the total downward force on this block by a magnitude of 14 Newton. Or we can say that N, that is the total upward force, minus the total downward force, that is 70 into 9.8, which is equal to 686. This has to be equal to the 14 Newton. Or from here the value of N comes out to be 686 plus 14, that is 700 Newton. So our option B would be the correct one. So thank you for watching. If you still have any doubt, please let me know in the comment section, and don't forget to subscribe to our channel Doubt Forum. See you in the next video. Till then, take care. Bye bye.